So let's start by reminding ourselves about probability and chance, and the probability scale, which goes from 0 to 1. The probability of an event happening goes from 0 to 1, so it's a decimal value. Or we can say that the probability of an event occurring after a trial, like tossing a coin, the event being a head or a tails. They have certain probabilities, and in words we might say that the probability of Sunday following Monday is impossible, but the probability of Sunday following Saturday is certain. Okay, so the more likely an event, the closer its probability is equal to 1, and just this is probability scale here. And we can predict some probabilities of events using common sense, like the probability P of a banana growing on a pear tree, that's 0, or it's impossible. And as I said earlier, something like the probability of Saturday following Friday is equal to 1. It's certain. Okay. Other times we can evaluate the probability of an event by considering all the possible outcomes, especially if they're equally likely. And we would have met with this in the junior cycle. Tossing a coin, heads and tails are the equally likely possible outcomes there. Or if we throw a dice, we'll get a 1, a 2, a 3, a 4, a 5, or a 6. So reminding ourselves of the old terminology, we'll just look at an example here. This is taken from the book. Yogurt is sold in packs of 12. Robbie takes one without looking. Okay, so we have the scale here where vanilla is marked on the scale, and so is plain, and so is berry, and so is nut on the probability scale. The chances of pulling a flavour that's either of those flavours. Okay, so what's the probability that Robbie will take out a vanilla flavour? Well, the scale has 1, 2, 3, 4, 5, 6 graduations. We're on the third one there, so it's in the middle, so it's even's chance, it's 1 in 2. And if that's the case, how many vanilla are in the pack? Well, we've 12 yogurts in the pack, times the 1 and 2 probability, there must be 6 in the pack are vanilla. And how many then would be plain? Well, 1 graduation on this probability scale is worth 0.166. Okay, and the plain is at the second graduation, the probability scale. So that's 2 in 6 times 12. Tells us that there's 4 yogurts in the pack of 12 that are plain. And the probability of Robbie choosing nut flavour is 0. Okay, and so that's that example. And just to make mention of the fact that we'll come across the words and probability of the phrases at random or a fair dice. Both of these mean that the outcomes are equally likely outcomes from the problem that follows. And also, the probability of something happening is equal to 1 minus the probability of that something not happening. Okay, so P of E, the event, is equal to 1 minus P of E not happening. And still reminding ourselves of the words we use in probability, like events, outcomes. So in probability, we perform a trial, and that trial could be throwing a dice or tossing a coin. Whatever trial we choose to look at, it will have outcomes, equally likely outcomes. So for the dice, you'll get a 1, a 2, a 3, a 4, a 5, or a 6. 6 equally likely outcomes, whereas if you toss a coin, there's 2 equally likely outcomes. It'll either be a head or a tails. And when we write down these outcomes, likely outcomes, that's known as the sample space. An event then is that desired outcome that you want. Okay, so if you were to perform the trial of tossing a coin and you were trying to find the probability of heads, heads is the event that you want. It's the desired event of the two outcomes that you want, and that's what you're looking for the probability of. Okay, and for trials with equally likely outcomes, we have this formula that the probability of the event that you want to happening is equal to the number of successful outcomes in the sample space, or favourable is another word, divided by the number of all the possible outcomes in the sample space. Okay, so we would go further to say that the probability of any event is always between 0 and 1. Okay, so if we have this spinner here, and we've 1 in 5 parts of the spinner shaded, then if we spin the spinner, the probability of it landing on the shaded part, this is the event we want it to land on the shade, is 1 in 5 possibilities. There's 5 possibilities in the sample space, but there's only one successful, favourable, desired outcome. These examples are taken from the Junior Cert book, but they apply in the same way for the senior course. Okay, a card is chosen at random from a pack of 52 playing cards. What's the probability that it will be a diamond? Okay, well, the probability that it will be a diamond is the number of diamonds in the pack divided by all the cards in the pack, 1 in 4. A red, the number of reds between the diamonds and the hearts is 26, 13 in a suit, 4 suits in a pack, 1 in 2. Black, same thing. Probability we get a 3, well, we have 4 suits, there's 1 3 in each of those, that's 4 of those, out of 52, 1 in 13. The probability you get a picture card, you have the Jack, Queen, King, times the 4 suits, there's 12 picture cards out of 52. The event is the picture, there's 12 of those in this sample space of 52. And the probability that you get an ace or a king, well, there's 4 suits, an ace and a king in each, so it's 8 out of 52, or 2 out of 13. Okay, another example then. Of 100 tickets sold in a raffle, Luke bought 10, Heather bought 5, and Anna bought 1. The ticket was chosen at random to see who would win. Okay. What is the probability that Alan won? Well, Alan bought 1 ticket in 100, so 0.01, or that he'd win. That Luke would win, he bought 10 in 100, so the probability of him winning is 0.1. Heather bought 5 in 100, so 0.05. And the probability that none of the above would win, well, there's 84 other tickets remaining in the 100, that's 0.84. And just note how all these probabilities add up to 1. And that'll always be the case. The probability of all the outcomes possible will add up to 1. Okay? How many of the 100 tickets would I need to buy for the probability of winning to be 3 in 10? Well, the way we set up these, we'll look at a decimal and a percentage. We just write our 3 in 10, equate that to the number of tickets we're looking for over 100, cross multiply, and we'll have 300 equals 10 times the number. So the number is 300 divided by 10 is 30. Same here, put 0.2 equal to number over 100 and cross multiply, and we need 20 tickets to give ourselves a probability of 0.2 of winning. And just bear with me. And if we want to find how we give ourselves a 25% chance of winning, then we equate 25 over 100, and we let that equal, because it's 25 per 100. Okay, it's the other way of writing 25%, is equal to a number over 100, cross multiply. We need to buy 25 tickets to give ourselves a 25% chance. And to give ourselves a 100% chance, we put 100 over 100 multiplied by number over 100, and we cross multiply, they'll cancel out, and we need to buy 100 tickets to give ourselves a 100% chance of winning the lotto, or the whatever it is, which is obvious enough. Okay, a game is played by picking a card at random from a pack of 52. The table shows the results of picking various cards. So an ace, you win €2. King, queen, and jack, you win 50 cents. 6, 7, 8, 9, 10 is no win or lose. But if you pick a 2, 3, 4, or 5, you'll lose 50 cents. So if Ellen's playing and she picks a card, find the probability that she loses. Well, to lose, she needs to pick a 2, 3, 4, or 5 from 4 suits. So that's 16 danger cards out of 52, 4 and 13. The probability that she'll win, well, the winning cards are here. There's 4 of them, ace, king, queen, jack, and 4 suits. So it's the same probability. The probability that she'll neither win nor lose, we've 6, 7, 8, 9, 10, with 5 cards, 4 suits, 20 over 52 is 5 over 13, or 5 and 13 chance. And the probability that she won't lose at all, the probability she won't lose is found by adding up the 1, 2, 3, 4, 5, 6, 7, 8, 9 cards times 4 is 36. All of these are the non-lose section. So 36 over 52 is 9 and 13 chances of not losing.